On page 5 now, let's finish up section 6 by looking at some of the application exercises, or the word problems or story problems, where you could utilize this knowledge of how to solve a quadratic by using factoring and the zero product property. Here's number 68 from page 463. And we're going to utilize our techniques that we developed in Math 60. We're going to read it, take a nice deep cleansing breath, read it a second time, and then employ our strategies of pulling out the information they give us, translating as needed, maybe even redrawing the picture, all those skills that we used in Math 60, or developed in Math 60. A ball is thrown straight up from a rooftop 300 feet high. The formula, h equals negative 16t squared plus 20t plus 300, describes the ball's height above the ground h in feet, t seconds after it was thrown. The ball misses the rooftop on its way down and eventually strikes the ground. The graph of the formula is shown, with tick marks omitted along the horizontal axis. Use the formula to solve exercises 67 through 69. And we're going to do 68 here in the notes. Just a reminder, when you're in the book and you jump right to the question you're supposed to be solving, if you don't see enough information, look up a little bit, because the given information might be a few questions above it. Just like this information applies to 3 different problems ahead of the, ahead of the 68. Okay, so here we're starting with, so we've read it. Let's take a deep breath. Let's read it again and pull out some information. A ball is thrown straight up from a rooftop 300 feet high. The formula h equals negative 16t squared plus 20t plus 300 describes the ball's height above the ground, h in feet, and t seconds after it was thrown. The ball misses the rooftop on its way down, eventually strikes the ground. The graph of the formula is shown, with tick marks omitted along the horizontal axis. Use the formula to solve exercises 67 through 69. And 68 says, when will the ball's height be 304 feet? Identify the solution as a point on the graph. So we've got 2 things we're doing. The goal here is, when will the ball's height be 304 feet? So our goal is when, which means time, so t equals what? So t equals what? When the ball's height equals 304 feet. And we were told that the ball's height is h. So h equals 304, and we want to then find t. So they give us this formula. We don't even have to translate to a formula. We just have to understand what they're asking, plug it back in, and use our skills. We can expect to use our zero product property skills here in the application exercises. Did I call it property again? It's really principle. Zero product principle to solve and answer these questions. So they give us h equals negative 16t squared plus 20t plus 300. And we want to know when the height is 304, if we are to replace the height with 304, then we want to know what t equals. So we want to solve for t after that. Okay. We have a quadratic situation because we have a t squared piece. What we don't have yet is standard form, where it's solved and equal to 0. I'm going to go ahead and move everything over. I'm going to add 16t squared to both sides. I'm going to subtract the 20t, and I'm going to subtract 300. I'm going to do the same thing over here. I'm going to add, I'm kind of out of room here, but so imagine I'm doing it all on the left here. I'm adding 16t squared, I'm subtracting 20t, and I'm subtracting 300. And what I end up with, and I'm going to let everything kind of shift so we can get it back on the lined part. I'm going to end up with positive 16t squared minus 20t minus 304 minus 300 is a plus 4, and that's equal to 0. So I moved everything to the left, combined the 304 and the minus 300, and then I just have 0 on the right. Now I've got a quadratic in standard form. So now I'm asking myself, how do I solve this? Well, it's a quadratic, so I start by a standard form, which we've done, and then I factor. Is there a GCF involved? Yes, there's a 4 in common. So I can pull out the 4, leaving behind 4t squared minus 5t plus 1. Again, still equal to 0. We haven't used that part yet. We're just trying to factor. So now number of terms that are left, 3. And I'm going to just time lapse here the factoring. Once you've done the factoring, you should end up with 4 times 4t minus 1, t minus 1. That first 4 is the GCF we pulled out at the beginning. The other 2 are the factors of the 3 terms that were left over. Again, if you're struggling with the factoring, let's refer back to 7.2, 7.3, those earlier factoring sections, and bring those questions to class. I'm happy to show you that. In the interest of time and space here, we're just going to assume that the factoring is coming together for you. We're going to focus on the skill at hand, which is zero product property. So now that we have it all factored, we have something times something times something equals 0. We now use the zero product principle, we'll call it ZPP, to set each of those equal to 0. Now this first one, 4 equals 0, that's not going to happen because 4 is 4. So either this first factor involving t equals 0, 4t minus 1, or this second one, t minus 1 equals 0. Remember we said there could be 2 possible answers here. So when you solve these equations, you get, again, a little bit of time lapse here. T is equal to a positive 1/4, and then t equals 1. I added 1, divided both sides by 4. Hopefully 2-step equations, you're getting to the point where you can practically do them in your head. Now, sometimes we've had extraneous solutions where we've had to toss one out because of the oh, actually, I think I jumped ahead here. Sorry, disregard that. We'll talk about that with the next one. So we have 2 solutions here. Do both solutions make sense? Remember that it started at 300 feet above the ground. It was tossed up, and then gravity, of course, brought it down. So would it make sense that it would hit 304 feet? Imagine us enlarging this graph here, zooming in on this one section here, where here's 300 and here might be 304, and it goes up and then comes back down. It might hit that 304 at 2 different times. On its way up, goes past it, and then on its way down as well. So it would make sense that it would hit it at 1/4 of a second as well as 1 second. So there are 2 possible answers here. 1/4 at 1/4 seconds and at 1 second would be our answer, when it would hit. And what are those solutions? Identify the solution as a point on the graph. So you've got 2 different points here where it would be 1/4 for your t value, your time, across the horizontal, and then it's at 304. And then a second one, 1 second, 304. 1 for the time and 304 for the height.